fix my shirt up before we go. Hello, everyone. Welcome to 96 Boards Open Hours. As always, right here, Robert Wolf, doing my best to host the show. Welcome. Yeah, so this is episode 60. We have another exciting episode in store for you. Lots of really cool things. And as you would maybe have noticed, there have been several announcements around Open Hours and 96 Boards in the past few weeks, or I should say in the past few months. A lot of exciting stuff happening. And one of our more prominent guests has been Arrow, right? And so in the spirit, I put on my Arrow shirt here from the I think this was from Bangkok 2016 Lenaro Connect. So very cool. In just a moment, I'm going to announce our guests. We have some people joining us from Arrow Europe. We're going to talk about the cool new mezzanine that has been floating around social media. And before that, as always, I do kind of go in a little bit to last week's episode and then give some announcements. So if you just hold tight, we'll get our guests introduced here. First things first. Last week we talked about the D3 DesignCore Camera Mezzanine, also available on Arrow from the D3 engineering team. This is a dual camera mezzanine that plugs on top of your 96 boards, and a very cool mezzanine, very cool episode. I have the link that I will share here for you. We have a landing page on 96 boards where you can find links to various resources, as well as videos from our out-of-box experience on YouTube, the Open Hours episode, and then, of course, a link to buy it from Arrow. Then we also have the videos on there and a nice little post-episode blog that I posted with timestamps. Thank you to Mani for digging through the video and pulling out every single important thing that happened in that episode and putting a timestamp to it. And then the chat log, which was just outrageously long. So many really cool questions, and hopefully everyone got theirs answered during that episode. For those of you who are interested in Lenaro Connect, I would like to remind you all that we have the registration page open, and hopefully we can get that link also shared in the chat. I believe it's lenaro.connect.org or connect.lenaro.org, but we'll get that link shared for you anyways. To this time, or this second half of the year, it's going to take place in Burlingame, near San Francisco, Bay Area, California. Very, very cool experience there for anyone who's interested in checking that out. Next thing, we have had several interesting blogs that have been pushed out. One came from Radhika, and she's probably on the call here. She's one of the 96 Boards interns. She showed us how to make several cool little interesting projects around 96 Boards. I think one was a digital hourglass and a magic 8-ball using some of the sensors that are available in one of the mezzanine kits on I believe, Arrow or Seed Studio. Then you have another blog. Thank you to one of our more involved community members, Sahaj Sarup, and YouTube influencer, Geek Till It Hurts. He wrote a blog on adapting the Arrow audio mezzanine board for the HiKey 960. So this was a pretty cool blog for those of you who are interested in using the Arrow audio mezzanine for any of your other 96 boards. You can follow that blog to kind of mod your mezzanine to work for all 96 boards. And then next, I want to remind everyone that we have the new projects page up on 96boards.org. I would suggest taking a look at that. There are a lot of cool projects that are surfacing. I think we're at over 60 projects now. I plan on adding another 10 or so more in the next couple weeks. So please keep your eyes on that page. There's lots of really cool things that you can check out and recreate. Great. All right, so I think that's enough of the announcements. Unless anyone else has questions about those announcements, you can speak up, interrupt me anytime. All right. For those of you who don't join us frequently on Open Hours, this is an open forum, right? I would prefer not to talk as much as possible, so feel free to interrupt at any time and bring questions to myself or any of our guests. Now, without further ado, we have Dieter and Attila on the call from Arrow Europe, right? Hi, Dieter. Hi, Attila.
Hi, Robert. Great to be here.
Thank you for joining us. Yeah, so you're joining us from Germany, right? Both of you?
No, I'm coming from Germany. Attila is joining us from Budapest in Hungary.
Awesome. Well, so in the spirit of usually what we do is we like to kind of offer you, I don't know, a couple minutes to introduce yourselves. If you wouldn't mind telling us something about you, what you do for Aero maybe, and how you're involved with Aero and 96 boards. Maybe take a minute for that.
Sure. So yeah, we are both coming from Aero in Central Europe or in the EMEA region. My personal role is working as a field application engineer, supporting our customers doing typical high-end designs in the ARM Cortex-A and somehow also in the x86 area. Besides the chip-down designs, we focus more and more also on system on modules and also on kind of single board computers, and this is where Linaro comes into this game. And so one of our key drivers right now is the 96 board program, and the software parts around the boards we do create, and also the ecosystem we do create around the computing boards with the mezzanine cards, like we want to talk about today.
Excellent. And Attila, did you want to kind of tell us a little bit about yourself? You have a second?
Well, I don't know. Can you hear me?
We can.
Oh, great. So, well, I'm joined Aero 2 years ago. I'm a member of the Engineering Solutions Center. So our team, it's a growing supporter team. We are supporting mainly the field application engineers, and also we are involved in such other projects like demo boards, making demo boards, and also we are now launched the online chat support on the aero.com, so everyone who can get there can ask us to help find the right parts and everything. So in the future I will be also participating in 96 boards projects. Currently in this device I wasn't involved, but in the future for sure we will have some more meetings and open hours.
And I look forward to that. Thank you very much for letting us know all this. Now you kind of answered the question, I guess, a little bit, both of you. But for those who aren't familiar with Aero at all, could you maybe give us kind of like a little bit of a background as to what exactly Aero does? I mean, I know if you go to aero.com, you can see it. You sell stuff, right? But I think you do more than that.
Yeah. So selling electronic parts is basically where we are coming from. So the company was founded many years ago, starting as a what is the right word, dealer for spare parts. Initially thought for radios and televisions. And from that time on, Aero expanded more and more into the more recent electronics. And till today, we are also expanding this to more and more services around that. So, for example, we are providing excellent logistic services for huge tier ones and also for the huge assembly companies like Foxconn, for example, or Flextronics, who are working globally. So this is, let's say, our traditional business where we're selling parts. But besides that, we are also expanding more and more into services, into more software related parts, creating kind of solutions for customers like we are doing with our mezzanine cards. So we are picking the right parts where we can ensure, for example, longevity, where we can ensure that the suppliers are providing support to the end users. So many parts are available which are great from technical perspective, but you do not get any support at all if you're stuck with your questions. And also this is a kind of support we offer. And more and more we are also providing software services. We are running our own cloud service called Aero Connect, where customers can really create IoT solutions, where we call it from sensor to sunset, where we can provide the parts for creating sensor nodes. We can create or provide parts for building their own gateways. We can also provide them ready-built gateways, and we can provide them also the services in our own computing centers, or connect them, for example, with Aero Connect or with AWS or with IBM Bluemix or whatever is available on the market. So this is far behind or far ahead of what we did in the past, and where we maybe in some heads are known about, but this is changing rapidly, and we are doing a lot, especially like this initiative we are doing with Linaro, to change this perception also.
Yeah, and so I mean, bringing up kind of what happened last week, right? We had the D3 Mezzanine. I think I have it up on the wall here. But for instance, from what I understand, Arrow also likes to help people, and this might have kind of been brushed on, come up with derivative designs, right? In their path to product, essentially, you purchase your Dragon board on Arrow, and then you purchase your mezzanine on Arrow, and then you realize that, hey, I have this really good idea. I built this product. Now I want to talk with Arrow, like you're saying, these services, to either acquire some of the chipsets that they were using and then maybe build some derivative product out of it, right? Derivative boards through you.
Yeah, so this is my, let's say, my daily business, to support customers who are getting in touch with their local Arrow sales office, for example, and having these ideas in mind. And then they, sooner or later, they will ask for some technical advice and technical support, and this is where we field application engineers together with our field salespeople are going on site to the customer, working on their concepts, providing them first prototypes, and bringing things, let me say, up and rolling. And as Attila mentioned before, these guys from the Engineering Solution Center are our kind of a back office, who are doing the work mostly in the hidden, but not less full of value. And for customers, this is a great thing because they get a ready-built kind of a suggestion where they can start working on. And yeah, these 96 boards, as mentioned before, is one of our strategic platforms, because this is the first thing ever happened before where you can create, let me say, platforms across different technologies and across different vendors, and everything fits together and everything can be directly compared.
Awesome. Well said.
Thank you.
Hey, yeah. So now, I mean, I kind of purposely moved this, extended these questions a little bit because I wanted to see if more people joined. And so we have the perfect amount. I think we're ready to kind of talk about this board that we're here for, right? And we're calling it at least on my end, I'm calling it the Power over Ethernet Mezzanine. Is that correctly?
Yeah, this is the official name.
The official name.
Yeah. So yeah, we combined a few technologies on that. We tried to fill gaps. One of the most often asked question I got when working with the Dragon board is why the hell they did not put the Ethernet on it. So for typical IoT applications, wireless technologies is for sure great, but at a certain point you are happy to have a cable on it, which you know that it is working. And so the idea was born very early to create a kind of a Ethernet card. But a pure Ethernet card was a little bit of boring, so we tried to get some more ideas what can be interesting, and so Power over Ethernet was very close to that. And besides that, I will talk about that more in detail later on. We put also a TPM module on the board to have a platform for also extended security applications, for example.
I actually have one of these cards here. I just kind of want to show it to the camera real quick. But I mean, this is a beautifully designed card. You can see one of the unique things that I found about this one was that when I plug it into the Dragon board, and I have one right here, I'm going to do this, is it rests to the side of the actual board itself. And I personally find this genius. I mean, so a lot of people might say, oh, well, why do you have it extending the form factor? I mean, people can complain about that. I personally like it. You can take another mezzanine, pop it right on top of this one, and then you still retain access to everything that's on the other mezzanine here with the Ethernet, it also doesn't disturb anything that would say plug on top of the other mezzanine. So I mean, stackable and extendable in my opinion, and I mean, beautifully designed. So we're going to see more about this, right? You're going to talk more about all the different features on here.
Yeah, especially the stackable thing was let me say a kind of a requirement. So we at least to have the possibility to put the the UART board on it, to have still access to the console. And yeah, so this was so we had a few discussions during the design if we put it on top of the board itself, which would have forced us to let me say to make some compromises, especially also because of heat dissipation. So if you really pull the whole power consumption which is available out of the PoE converter, it creates a certain amount of heat, which sits then directly on top of the processor. So we had a few discussions, and this showed up as being the best way to do it. And I'm happy that you are happy with it.
I'm happy with it. I just plugged in the audio mezzanine here on top, right? But it could very well be stackable underneath if you wanted to bring out the audio parts. But I mean, here you have a full system. You have access to all of your I/O. You have ramped up, or your rails have been ramped up here to 3.3, 5 volts. If I put this one in between the Ethernet mezzanine and kind of sandwich this one, then I would also have access to the audio outputs from the Dragon board. I mean, yeah, I personally love it. So, Dieter, are we gonna? I was told you have a presentation for us. You want to kind of talk to us a little bit more? Or did you have anything else you wanted to address before we go into that?
Yeah, we can dig into a little bit more into the details of the board and doing some small demonstrations with it. So I think for most of you this was daily business, but for the newer ones this is maybe somehow interesting. So I will try to share my screen. Please let me know when you see it.
Okay, so I see it. I just want to let you know real quick, on the top left side of your screen, that will be covered by your face or whoever's talking. So whatever's on the top left will not be seen. Sorry about that.
No worries. Okay, yeah, so 1 second. Okay, yeah, so the agenda for today's sessions. I would like to introduce some special guests. I will give you a short overview about the board, talk a little bit more about Power over Ethernet, what it is good for, to give you maybe some ideas what you can make use of it, how to create some nice and cool fancy demos. And then we will have a look at the board itself, running some commands on it, and doing some basic benchmarks. And yeah, finally maybe we can talk also a bit what is coming next and what we can do to make this board as much useful as possible for others.
And I would just like to to remind everyone that if you do have a question, please post that in the chat for now, and we'll address that as soon as possible. Sorry, go ahead. Take it away, Peter.
My special guest, one of them you already are aware of. This is Attila. So he is of great help, and he is supporting us a lot, and especially for the next project. You will hear a lot more of him. And my second special guests are two guys who you know very well. So they are sitting here, be near my desk, and it was told me that they have a certain experience with Linux, so I thought it is good to ask them for some advice when I stuck. Hopefully you do have some guys as well.
So yeah, Sahaj actually was in the chat right now saying how he wants one. I have my guys up here.
Yeah, this is great.
Welcome.
Yeah, as mentioned in the very beginning of our call, so we thought about what really is needed, especially in our, let me say, more industrial commercial customer base. So this is maybe one difference between the community usage and the more professional usage, that at least in the industrial areas where we are working on, where you have a lot of electromagnetic interference and a lot of electromagnetic noise, wireless technologies are not that familiar as it might be in some consumer applications. So we get these questions very, very often, how to connect Ethernet on it. And in the beginning, we bought dongles from our stock in to just connect them to the USB port. But it turns out very quickly that these ready-built dongles are using chipsets which are pure consumer oriented and which are not that, let me say, working very well in extended temperature range and such things. And so we had a look at the portfolio which is available from the industrial area, and we ended up very soon with Microchip. So if you had a look later on to the USB subsystem, you will notice that they are not recognized as Microchip but as SMSC parts, and this is from a former, let me say, merge Microchip did with SMSC. So the networking products are still marked as, also the latest ones are still marked as SMSC in the product ID. Yeah, and this one we are using here is the latest LAN 7850, which is a USB 2.0 to Gigabit Ethernet bridge. So at least you have the full link speed of Gigabit. You do not interfere anything in your, if you set up a pure Gigabit network. For sure, you did not reach the full Gigabit wire speed. But this is also not, or this was not the intention. The intention was to have a stable solution which provides you a certain amount of performance at a reasonable price, let's say. Besides that, as also mentioned, we have some hardware asymmetric engine which follows the TPM 1.2 standard, and a PoE plus power device power supply on it. And this is then a little bit explained more in detail. So a closer look, Robert already showed the picture. So this is how it looks like if you connect these boards together. And so we did not break the depths of the whole system, and we also avoided to cover the antennas of the wireless interfaces. So especially, for example, for some kind of access points or something like that, you will not degrade the wireless performance in any way by adding the Ethernet card on top of the board. And you have full access to the low speed and the high speed connectors. We tried also to prevent any interfere of the Ethernet card with other IOs. So the only IOs we are using are the I2C for the TPM and the USB line where the USB bridge is connected to. Yeah. As a whole test system, we offer to our customers some kind of assembled kits where we are using microsemi power injectors, which are out of the shelf products, which are ready built and housed, and so you can buy them at Amazon or wherever you want to have them, or at Arrow. And besides that, we also provide some application notes and some development tools and kits based on the linear technology power injectors. So you can create your own PoE infrastructure solution based on that kind of a reference design.
Dieter, I don't know if you touched on this yet, but what are the benefits of using power over Ethernet versus powering it through the DC jack? Did you already talk about that?
Not yet. So good question. The biggest advantage is that if you want, or if you need to have Ethernet and you can combine this with power over Ethernet, you only need one cable which needs to be provided to the device, and you get rid of the wall socket. and especially for applications like, for example, access points, IP phones, whatever you can imagine in that direction, you usually do have a working PoE environment in many areas, and this can be easily used for also powering the board itself. So the PoE supply provides roughly 30 watt. I will also go into more details later on. So you can power for sure the Dragon board itself. And we also put another 12 volt DC connector on it. This is the green screw terminal you can see here. And this screw terminal provides also 12 volt, which you can, for example, pull out of the device and supply an external TFT screen. So you can build a whole HMI solution powered over Ethernet without any soldering or anything else on the board.
So that's a 12 volt output, but not an input.
Yes,
you can't power from there.
It's a 12 volt output. Yes.
Okay.
Mm-hmm.
Great.
Yeah, and having a closer look to the board itself, you can see that there is, or as you can imagine, there are 3 areas on the board. One is the Ethernet area, which you can see here. So you see the USB to Ethernet bridge, and the what is the word? The MagCheck, which is the RJ45 connector with integrated magnetics, and basically that's the whole Ethernet part. And the magnetics are also selected in a way that we are able to pull roughly, I think, 24 watt in average, and up to 30 watt in worst case scenarios without any issues. Yeah, so this is the Ethernet port. As said, it's connected to the one USB line which is left on the high-speed connector. So this line is then blocked, and if you want to enhance this, maybe we have to consider doing another board between with an integrated USB hub to be able to have a few more ports. This was also something we considered, but to create a hub plus Ethernet, but we ended up with too less space on the mezzanine card, and so we decided to drop this. Yeah, the link rate, as mentioned, is 100,000 megabits. So you have auto negotiation as this is standard, let me say, for today's Ethernet devices.
Dieter, so I'm noticing, I'm sorry, I'm looking at the board and I'm seeing all these little voltage nodes: 3.3 volt node, 1.8 volt, 1.2 volt, 2.5 volt. These nodes, they're used for testing purposes, or is there anything else that they're used for?
Yeah, you can use them also for pull out or to get access to the voltage rails, but basically they are for testing purposes, because we wanted to have a very good let's say coverage of the existing lines and see if our PoE power supply interferes somehow with the existing voltages. And so we put also on top a few measurement points, because we are not able to measure on the carrier board once the Ethernet mezzanine card is plugged onto it. So that's the reason.
Cool.
Yeah, then you can see a small fuse. This is the let me say, this is done to prevent the board from firing up if you pull too much current out of the regulator. Without usually in today in commercial devices, if you do that, then your board is bricked. And we wanted to avoid this because it's a kind of a evaluation platform, and so the worst thing what could and should happen is that the fuse is broken. So if it stops working, have a look at the fuse and replace it, maybe not by a iron wire, so just by a new fuse if possible. And yeah, so that's the Ethernet part. And going to the TPM, this is something we are working on. this is also where Attila put a lot of effort in it, also with other TPM vendors, but we thought about that this would be a good thing to have also on our Ethernet card. So security is getting more and more important, but sadly, most of the chip vendors are trying to hide security as much as possible, and so it's very hard to get access to a, let me say, to an open platform where you can really work on, for example, the Trouser stack for integrating the TPM into the Linux infrastructure. And so we decided to put also here a TPM. We chose Atmel as vendor because Atmel and Microchip belongs to each other, so it makes it more easy for us to have support from one hand. And yeah, so this TPM gives you a lot of possibilities, especially if you need to have, for example, true random numbers. So you don't have to deal with initializing your random number generator in Linux in the correct way to have a good seed. This is all done by the TPM itself, so you don't have to worry about that. And if you load the drivers and if you use it in the right way, then you get some goodies, let's say, for free. And in later, or let me say later this year, we will also release some much more information about how to use a TPM. We want to connect this also somehow with your trusted computing group if this is working somehow. And we are working closely together with, in that case, with Microchip, but in other projects also with Infineon on bringing this forward. Yeah, and last but not least, the TPM is really good for storing keys. And really storing keys in a safe way. So at least here in Germany, we had a couple of very bad stories about routers, for example, where passwords are stored in clear text on the file system, where hackers can easily get access to your credentials. And to really avoid floating passwords around, TPM is a very good way to store them. So you have to have, let me say, a really strong, a really strong reason to get access to it, and it's not accessible for, let me say, daily hackers. So you really know what to do to get access to TPM data. This is somehow standardized via the trusted computing group. The modules, so the trusted computing modules are tested against different criteria, and so this should give your environment a certain amount of security without a high cost adder. And yeah, as said, this is something we are looking also for interested Linux hackers who want to do some more stuff on that. If you are interested, I would be happy to get in touch, because for sure we can do some common activities based on that. Yeah, that's basically talking about the TPM. So the drivers for the TPM are already in the kernel. You have to enable them. This is where Attila is working on right now. And yeah, based on the kernel drivers, then there are some software stacks, Trousers library from IBM, as far as I remember, initially built, and this library gives you a lot of good interfaces to work with the TPM, to initialize it, to store your passwords, to create the different levels of security you do need. And what I would like to do, for example, in the future, is to create a whole verified boot scenario where we can use, for example, a secure boot mechanism on a SOC, and then chain the different stages, for example, hashing the different partitions, store the hashes in the TPM, and measure the boot against these hashes to get aware of if your file system image has been changed or not. This is, for example, something we imagine working on. Yeah, and last but not least, you have a small NV storage on it where you can store configuration data or whatever, which should not reside in the eMMC, where you don't have to take care about overwriting them when you flash new images, for example. That's basically what we have in the TPM module. Are there any questions regarding TPM?
Well, so Dieter, a couple questions popped up in the chat here. One
Okay.
from Mani. It says, how well is the wiring for USB in this mezzanine? Is this connected to the USB hub on the Dragon board or to a single OTG port?
No, it's the Snapdragon 410 is only having one on-the-go port and on the SoC level. So this port is connected to the over a switch. It is connected to either the on-the-go hub on the board or to the USB hub. And we are using one output or one downstream port of the USB hub for connecting the USB to Ethernet bridge to it. So it shares, in other words, it shares the USB bandwidth with all the other USB ports.
Okay, and then Sahaj asks, on the Gigabit Ethernet, is it full duplex or half?
It's full duplex. And we are reaching, so I show some figures later on, but we are achieving roughly 120 to 130 megabit throughput. Honestly, I need to dig a bit more into that. It looks like the driver is the bottleneck. The card itself produces, connected to a standard PC, for example, connected almost 400 something megabit. So it achieves the full USB bandwidth. So the bottleneck is not the chip. And from my tests I did so far, the bottleneck seems to be also not the Snapdragon processor itself. So the system load is not that high that this should limit it. I need to check the interrupt load. So maybe this is some kind of limitation where we end up. On the other hand, this is also some values we see from other embedded platforms where Gigabit is connected via USB 2.0. So let's say we are not at the very high end, but we are also not really bad.
It looks like there was a follow-up on the USB question. John Mark asks if you lose any USBs.
On the board itself, no, because the port on the high-speed connector is a separate output of the integrated hub. So the two ports on the Dragon board itself are still remain in a working state.
Okay, and then one from Guillermo asks, Dieter, one other thing, or actually this is more of a comment and a suggestion, which is also appreciated. Dieter, one other thing that would be interesting to have on this board would be a real-time clock chip.
Yeah, this is a good question. Maybe I will have a look. So most probably we will be not forced to do a redesign. So everything works as far as I can see. But if we are forced to, I will consider this to put this on the board.
All right. Another question from Mani is, I think in this case we shouldn't connect any high-speed devices to the rest of the US. I don't know if that's a question or a comment. Mani, you wanna add a little more to that?
So I was just replying to the John Mark's question. So I think since this mezzanine is sharing the USB hub port, so if we connect any high-speed devices to the rest of the USB port, it will create a contamination, I guess.
Yeah. So the downstream port of the hub is then blocked by the Ethernet bridge. Correct. But the rest of the high-speed connector can be used for other things. For example, for cameras or whatever you want to, or for displays or something like that.
Now, did that help you out there, Mani? Are you set on that one?
Yeah, that's fine. Yeah.
Okay. So from Thiago, is named Thiago Lima. He says, does the PoE power all the board? I'm guessing he means, and you mentioned this already, but I'm guessing he means by powering the Ethernet mezzanine, you are also powering the baseboard, and you said that it does, right?
Yes, exactly. This is the intention, to have a, let me say, a completely independent powered board just supplied via power over Ethernet. Yes.
Yeah, that's good. And he's putting wow with the emoji. Yeah.
Are any of the Lowspeed connectors blocked? I noticed you haven't used
I'm
a
sorry,
through
Daniel, why
hole.
don't you ask that one more time?
Are any of the pins on the Lowspeed connector blocked? I noticed you haven't used a through hole connector. Is that so that you can block pins on the Lowspeed as well?
There are a few blocked, yes. For example, we are using one GPIO for resetting or for enabling to reset the TPM. We have the I2C port connected to the TPM, so this is not really blocked then, but you have to be aware of address conflicts, something in a certain way. And as far as I do have in mind, this is the only thing we are using on the Lowspeed connector. The schematics will be opened on Friday, I guess. Robert, I think we
So
agreed on Friday putting everything on the website. And then you have full access to the and then you do have full access to the schematics.
Yeah, so as soon as all of these documents are available, and these were some more questions that I was going to save for after the presentation, but as soon as all these documents and stuff are ready, I will provide them on the website, the one that I'm sharing right here. So we already have a power over Ethernet mezzanine landing page on 96 boards. You can see some images, and then of course a description that was written up by the Arrow team. There you'll find all of the resources that you need, as well as a link to purchase this board when it becomes available. Now, I'm not sure if you have this information for us yet, Dieter, but do you know how much this board is going to cost?
Yeah, we are targeting something around, let's say, roughly $60.
Okay.
And yeah, so this is where we want to sell it, or via arrow.com. Besides that, as already mentioned before, if you're in your certain region, if you're really interested in that for a more commercial product, so just get in touch with one of your Arrow representatives, and usually they do get you these boards for free to support your design work. And also, as also mentioned before, if you have plans to bring in some value in terms of doing software work, please let me know. We will support you with the hardware to make your efforts as low as possible, and to let you concentrate on doing what is fun.
I think that sounds like a call to arms. So
Yep.
anyone who's interested in doing some pro bono fun work on 96 boards and this Ethernet mezzanine, Dieter sounds like the guy you want to reach out to.
Yeah. So what I, for example, wanted to do in the next few weeks is to create a small own cloud box. So that is something which could be really cool.
Great. So now I love it because I'm seeing people, like do some math on the screen here. Ohm's Law, P equals IV, all this good stuff. What Sahaj asked, what's the max current that the power over Ethernet can provide, right? And then Rajan comments 30 watts. Tayet comments 25.5 watts. But I think that it is 25.5 based on the description, right?
Yeah, so the PoE Plus standard itself provides you provides you 30 watt. But you have to calculate a little bit on the wire losses, and therefore the devices are only allowed to draw 24.5 watt, if I have it right in my mind. And so the difference is reserved for security margins, to ensure that everything is in a stable state. But as said, we can convert 24.5 watt out of the PoE Plus power source equipment, and these roughly 25 watt are available for the local usage at the Dragon board. And as mentioned before, this can be used, for example, very good for powering a display together with the Dragon board.
Okay. So Dieter, I want to let you finish this presentation because it looks like we still are getting a couple more questions. That way, at least when you're done with the presentation, we can see your full face. So
Okay.
Yeah. So go ahead. And then we'll move back into questions.
Yeah. So this is what is little bit more details about the chip we are using. Also, there the documentation of the chip is available freely in the internet at the Linear Technology, or now they are merged with Analog Devices. But I think the web page is still accessible under Linear Technology. So you get access there to the data sheet and can dig a bit more into the details. For your information, for the ones who are getting their hands on the board and starting to solder, we implemented a fully isolated power supply with a transformer in between to have as less influences to the board and also to you as possible. What I wanted to mention before, there are some very nice use cases where you can make use of PoE. One was already talked, or what we already talked about is the access points, for example, but also surveillance cameras, something like post terminals, or many more things. For sure, you will also have some ideas for your home to connect your, I do not know, your weather station or whatever. For all of these things, especially if you cross a few levels in your building, wireless is somehow shaky, and so if you have a wire at all, then you can easily use a power injector and power the whole thing via the Ethernet cable. Some cool projects, for example, I could think about doing blogs about were some kind of digital signage applications, where one of our upcoming products also fits very good, and some kind of IP cameras or something like that, surveillance cameras, where the Snapdragon also fits very well into that kind of applications. From the power budget we already talked about, so we are in this area at between 14 watts and 30 watts. Behind that, there's also some additional standards, but at least what we can see in our typical use cases, these are very niche-y, let's say. Then we did some tests running on the board. I just provided you the screenshots and the commands I used there. In ifconfig, you can see what is a very interesting information, that we have no packet errors, which gives us a good feeling that we did the layout right. Besides that, we also put one board into the Microchip labs, and they are running a full IEEE test right now, that the device is conforming to the Ethernet spec from the IEEE. And this is also an important thing. If you really work on commercial products, then you can ensure that the full design is really bulletproof, and this is what we ensured doing these tests. And with USB devices, you see the different USB devices on the board. You will also see most probably my plugged-in HIT device, and on the very lower end you see the LAN 78XX device. Running the latest Linux Debian image from Linaro, the driver is already integrated into the kernel, so you don't have to do anything, just flashing the image, connect the board, and it's up and running out of the box, which is very nice.
Sorry, did you test this on the latest build for Dragon Board on the 17.04.1?
Yes. Today,
okay,
a fresh download and test, but also on the build before it worked.
Great.
Then I did some basic benchmarks. I run iPerf3, so this is what you have to install with apt-get on the Dragon board. Running iPerf3 on the host and on the device. You can run this on either Windows or Linux machine. Because of my company and firewall settings, I preferred to run the client on the Windows machine and started the server on the Dragon board. but you can also run it the other way around if you have access to your firewall ports. And you see what I talked about before. So we are roughly in the range of 120 something megabits per second. And this is where we are right now. We are investigating with Microchip if there is a way to enhance the speed. And if there is a bottleneck in the driver, we can easily work around to get to a higher speed. I would imagine from what is available on the market that at somewhere at 170, 180 megabit per second, the end is achieved with this class of processors, let's say. So then you need to go to bigger machines, to USB 3 ports, to really achieve gigabit speed on the Ethernet side. Yeah, that's basically what is on the board. There are also some tools available from Microchip to set the MAC address to a defined to a real defined MAC address. Right now they are created dynamically on the fly, and if you want to avoid this and want to ensure that your MAC address is really set always the same way, then please have a look. We will also provide you an app note for the website, Robert, where this process is described and what tools you need to download from the Microchip site and how to use it to program the MAC address.
Great.
Yeah, that's basically what we can do with that board. Now it's up to you to have fun with it and to create some nice applications around that.
I'm sure we'll see some cool projects popping up on the projects page soon.
Yeah. So if you have some additional questions, we can go into the questions, or I can give you a short outlook before what we are doing in the next few weeks, maybe 2 to 3 months time frame. What you can expect.
I just caught a glimpse of your next slide. Let's take a look at what's coming up, and then we'll just kind of open the floor for free for all.
Okay, great. Okay. Yeah, what is coming up from Arrow? I put together a small kind of a roadmap. Robert is maybe already aware of some of this stuff. So the next thing what will arrive is a board we call Meerkat. And this is based on a I.MX7 part from NXP. And Bill is already working on that to bring this into a good shape. And so this will happen hopefully within the next few weeks, let's say. I.MX7 is a very interesting platform because it combines a Cortex-A class processor based on a Cortex-A7 together with a Cortex-M device, where you can offload very power-saving tasks, or where you can offload real-time capable tasks, for example, controlling motors or something like that. And they control via a well-defined IPC mechanism between Linux and the RTOS running on the Cortex-M. This is a very cool platform, I think. Then we are working heavily on bringing Oxalis to the market. Oxalis is a more networking-oriented processor based on a Cortex-A53 with a few network accelerators to achieve real wire speed gigabit Ethernet switching and compression capabilities on a small single-core Cortex-A53 running at roughly 800 megahertz. With a power budget below 1 watt. So this is for entry-level routers, gateways, let me say all kind of data movers where you want to achieve a certain amount of throughput with a very low power budget. And yeah, the other one, we call it AND, will be a very small but powerful board, and maybe we can talk about in one of our next OpenHours session a bit more in detail. But this will then be the third member of our let me say different processor platforms. Meerkat and the new AND will be also a consumer edition. Meerkat is a standard CE and AND will be a CE extended version. And Oxalis is based on the, what is the name? Help me.
I'll mute. 1 second. Can't find who that is. Here we go. Sorry about that.
No worries. Yeah, so and Oxalis is based on the Enterprise Edition form factor. So more server-oriented platform. And then we are working on a bunch of mezzanine cards. So the first one is already announced last week in the OpenHours session, the D3 Camera Mezzanine card. The Ethernet mezzanine we already talked about. In a very short scale, my colleague Bill Davis, I don't know if he already joined our session. He is working on bringing a LoRa mezzanine card out in the next couple of time. LoRa is a very let me say a long range network with or wireless network with a low throughput for handling, for example, sensor data, but combined with a board like Dragon board, you can also think about systems where you transfer pure information via text, and the board renders this information into a nice screen, for example, to create kind of digital plans for buses or for railways or something like that. So this is a very interesting technology, and for sure we will work on making the Dragon board a kind of a LoRa gateway, and so stay tuned. This seems to be a really interesting platform. And what I maybe somehow mentioned already before is that we are working on a mezzanine card called Tresor, which is a full-featured TPM board based on TPM chips from Infineon, where we provide the whole security technology which is available today as a mezzanine card to have a platform to work on the software stacks, on creating scenarios for device authentication, for device or for creating encrypted channels between a gateway and a small node, or the gateway and a web service, a cloud service. And last but not least, we are having already in our line card a fingerprint sensor for authentication. This is maybe something we need to speed up, and we also need to find a way to open the software. So the blocking point right now here is more the software side, because sadly this software stack is not public available without signing an NDA, and this prevents us right now from opening this to 96 Sports website. But this is work in progress, and hopefully we will find also a solution for that. That's it basically. So you see, this is what we want to do with Tresor. So for the ones who are interested a bit more in that, this presentation is also shared on the website, and you can have a look at it.
Yeah, so definitely awesome. Yeah, so definitely you plan on sharing the presentation with me so that we can post it on the website and maybe write a little blog about it?
Yeah.
Great, great.
Sure.
Yeah, so you can all expect a blog with maybe some timestamps for important things that happened, which is pretty much the entire episode. And then, we'll get this slideshow available for everyone.
Mm-hmm.
All right. So it looks like you took off the shared screen now.
So you should see my big picture now.
Yeah.
Thank you.
All right. So let's get some of these questions answered. A few more popped up. First one is up the list. Mani asks, does this mezzanine have EEPROM?
We have no. Sadly, we had not, or we were not prepared early enough to have an EEPROM on that as well. I know that you guys are thinking about some usage for this EEPROM. So also this is on my list. If we do a redesign, for sure we will have a EEPROM. The TPM board will be the first one where we have this concept on the board from the very beginning.
Okay, that answers it. Tyeth asks, do you have plans to implement the 90 watt 802.3 BT version?
Not yet, but if we see a demand, this is not let me say, not rocket science. It's just work we need to do. If you're interested in that, you can also get in touch, and I can provide you some other evaluation boards or boards to start some kind of evaluation.
Can I follow up a bit on that question? It's saying that the motivation is that there's very little power budget left after the Dragon board. Now, the Dragon board is usually attached to a 24 watt power supply, but 17 of those watts are to allow the Dragon board to power other things. Right, so that's to give you the power to run USB and to run the top board. So you're allowed to deliver, was it 12 watts? You can deliver quite a lot of power across that low speed connector. And of course, when you're using power from the top board, the Dragon board won't be consuming it. So you should have a good 10, 15 spare watts, I would have thought, in the current design.
Mm-hmm. So I hope for many applications it's quite enough. So maybe you have more experience with that. How many power you needed for past projects, for example? If there was already a bottleneck, from my experience, usually you do not have to draw too much power out of the board, as long as you do not think about motor control or high-end power amplifiers for audio or something like that. So the typical consumption for small electronics is a few watts, and I think the Dragon board is somewhere at 5 watt roughly, and so you have about 20 watt available for your own usage.
Okay. Daniel, you got any more, or I'm gonna move on to the next one?
No, it was just a question about how little power is left. I think I was just checking that it wasn't the assumption that the Dragon board needs 24 of the watts. You put a Dragon board on a 24 watt supply, and there will be 17 left over for other things.
Yeah.
Cool.
Speaking.
Yeah. So the next one comes from Kaio. Kaio asks, "Is there a price yet for the Oxalis board?"
This is in negotiation. No, I cannot say you a real number. So we are targeting something around 200 bucks, but I'm not sure if we really can achieve this.
So target, but don't hold him to it. Yeah. Next question.
So for Oxalis, it's really challenging because we have a lot of stuff on the carrier board to make use of most of the features the LayerScape processor can provide, and this drives the cost a little bit to the upper end. And additionally, the memory prices are growing like hell at the moment. But yeah.
And I shared a video there, just one message down from that one, or a couple messages down, a video that Dieter made with Charbax at what was it, Budapest Lenaro Connect 2017. So earlier this year in March, and we actually show the Oxalis board there, the module that goes on the baseboard and everything, and then Dieter talks a bit about it. If you want to take a look at that video. The next question from Kaio, same one who asked about the price for Oxalis. LoRa Mezzanine, based on SX1208, build gateway LoRaWAN? LoRa, question mark? I'm kind of wondering how to read that question there. So maybe if you want to rephrase that. Maybe he means, is the LoRa Mezzanine based on SX1208?
Oh, I have to have a close look what is really based on the chip. It's a Semtech chip for sure, but the exact number I do not have in mind.
Okay. And then Tyeth asks, can you go back one slide? So it's a little too late. Sorry. Sorry about that, Tyeth. So he's interested in the TPM board. I don't know if you had any questions in specific about the TPM board that was mentioned, Tyeth, but we'll get to that if you want to type that in. And then we have Sahaj, who asks, is there a planned revision for the audio mezzanine or something like that?
I'm not aware of that, but we have to also ask Bill if there is a plan in the Americas. But I'm not aware of that right now.
Okay. Another question from Guillermo is he sees a micro semi list as one of the board's sponsors. What chip are you using from them?
We do not use really a chip from them, but we tested against their power source equipment and especially their PoE capable Ethernet switches. So they have a very, very broad portfolio of ready-built PoE switches and power source injectors, and we tested against them and make sure that we are compatible against their products.
Okay, cool.
There's also another question related to microsemi from Guillermo as well. If we have plans to develop a mezzanine board with microsemis FPGAs. Basically, yes, we thought about that a lot of times. The issue I do see, but maybe we can talk about that offline, is how to connect the FPGA in a certain speed to the Dragon board. So the Dragon board sadly has only USB ports for let me say higher speed connections, and UARTs, or the quickest what is available is an SPI port to connect to the FPGA, and so so we are thinking about that. What makes really sense to have a high-speed FPGA connected to a low-speed connector, and how to offload tasks. But this is for sure something we are thinking about. Yes.
Okay, great. Hope that answers your questions there, Guillermo. Then John Mark asks, will the LoRa board only be supplied in the United States or everywhere else? I think he's going based on the flags that are on the right side of your presentation.
These flags are coming from our internal, let me say, split, where the efforts try to split up or across the regions, and the flags where you have the American flag behind are maintained and driven by Bill Davis, my colleague in Denver, and the flags where you have seen the European Union on it, these are the boards coming out of Europe. But this has nothing to say in which region they will be sold. So all of the boards will be sold over Arrow.com globally. So the only poor guy is Sean Mark, as far as I heard. He in Switzerland, this is somehow special, and maybe also in some other regions. If you know a local reseller, for example, who are selling kind of community boards and such things, we can get in touch with them and ask them if there's a way to sell the boards to this reseller and open this markets on that way.
Great, cool. So hopefully, yeah. It sounds like some countries are of course limited, right? I mean, that's just kind of natural. Coming from Kaio, he asks about the Oxalis board again. He says, is the Oxalis form factor, will it be compliant to the 96 board standard since it's a board based on system on module?
Yes, we covered all 96 board Enterprise Edition standard requirements. We had a long discussion with Young about that, but yes, we are compliant.
Okay. And then Kaio
This is an enterprise board here. This is a CE board. So there's loads and loads of space to be 96 boards compliant and to have space for your system and module.
Yeah, and if you go watch that video again that I shared, you'll see the Oxalis board. I think we even pop off the module, show the module, talk about it, then pop it back on the board. And then after watching it, I realized I popped it back on upside down. But I mean, it's there. You can see the board. It looks like Dieter's going to grab one right now.
And the Enterprise Edition. The Enterprise Edition does not have a high-speed connector. So any board that you've seen from Arrow with the high-speed connector on it, like that Arrow Ethernet board, will not work on Enterprise Edition boards. That's a deliberate design decision because most of the high-speed connector is there to connect cameras, and the cameras don't really make sense for Enterprise. So that connector is not present. So it's not the case that you can plug everything in. The 40-pin connector is still there. So a lot of mezzanines will work, but not all.
So this is the carrier board. I don't know if you can see it. This is the carrier board of Oxalis, and you can see here the SOM board-to-board connectors where the SOM fits on it. And we also thinking about, or we when designing the connectors and the system on module, we also thought about creating a kind of a platform for upcoming layerscape processors. And so the intention was to keep the efforts as low as possible and make reuse the carrier board for different system on modules. And yeah, you find all important interfaces. You have USB 3, you have Gigabit Ethernet 2 times, you have PCI Express, you have SATA, and you have the low-speed connector as mentioned by Daniel. Yes.
Great. Kaio, it looks like Kaio rephrased his question from earlier about the LoRa mezzanine. He says, okay, I reformulated my question. Will the LoRa mezzanine be based on LoRa end node, or can we use this mezzanine to build a LoRa gateway?
Basically, you can do both. And I think especially connected with 96 boards, it makes most sense to use it as a kind of a gateway. Because for nodes, I would expect that the boards are much too expensive. The 96 boards, carrier boards, but for gateways, these are the perfect platforms.
Alrighty, and then the question of the hour here by Sahaj, since of course it wasn't on your slides, but is there any update on the Chameleon board?
Yeah, we are working hard on bringing this out as well. As I was told beginning of this week, there is still some challenge with the SD controller inside the FPGA, which is also somehow related to legals. And yeah, this is what we are working on. Most probably we have to rework this on the IP side. But yeah, sadly we are not yet in the position to push this forward. That board is also very cool.
Awesome. So I'm sure I want to let everyone know, and I'm sure that Dieter will join us again, as well as other representatives from Arrow, as more of these boards become available. Right? I think that we can. You said that you would, right? We can count on you for coming on here again and talking about some more fun stuff.
Sure, I'm very happy to be here, to have this opportunity, and hope it was somehow interesting for you folks.
Oh, I loved it. I'm pretty sure everyone here really enjoyed it. The last thing I think we want from you, Dieter, is for you to play us a song on your guitar that you have hanging.
I think we postponed this to.
Okay. All right. Next time then. Next time.
Yeah.
Great.
Okay.
So, are there any other questions on here? We've gone about 15 minutes over the hour. That's a little unusual. I don't like keeping people here that long on the recording usually, but I mean, we had all the questions, so definitely worth it. I will give people a couple more seconds to get any last questions in there. And then Dieter, do you have any closing remarks that you would like before I go into kind of the closing announcements? Lock this up.
First of all, thank you very much for your interest and for your questions. So this is very, very valuable input also for me to take care doing the next boards and consider these things. And yeah, so from my side, I'm happy, and it was great to be here.
Well, then on our side, thank you so much, Dieter. Yeah, thank you for being here, and thank you, Arrow. Thank you, Arrow, for allowing Dieter and Attila to join us. I'm sorry we didn't get too much talked. We didn't talk to you so much, Attila, but it was definitely very grateful for having you here. Did you have anything you wanted to close out with?
No, nothing.
Okay, great. Well, we hope to hear from you more in future episodes. I'm going to go into the closing announcements here real quick, if you all don't mind. Great. So, as always, once again, thank you. For those of you on Facebook, I would encourage you to join us next week. We're here every week, 4 p.m. UTC, www.96boards.org/open hours. You can always find us on IRC channel 7 days a week, 24 hours a day. IRC channel #open hours. For those of you who are interested in signing up for our, what do we have here? For signing up for our community forum, we do a forum every week that's available to you in the Open Hours chat. And we give you this forum. You can get community points. We have yet to give anything out on the side using your community points. But let me see. Oh, shoot. He's getting a 404. I'm going to share this in just a second after I close out the recording here. But the forum is for community points. I've mentioned this in previous episodes. The person with the most community points, we desperately hope to give a free badge to our Lenaro Connect in Burlingame. This is valued at around $2,000. So definitely a good prize for, coming in and just having fun with us, in the morning with your cup of coffee. On top of that, please check out our blog section, our new projects, and find us on our forums. Daniel Thompson, who was on the call earlier, he's our main support lead for the 96 Boards forums. You can find it at 96boards.org/forums. Once again, thank you, and we will see you next week. Take care. Recording's going off now.